Dear students, welcome to the next lecture. Today we are going to talk about the basic concepts of electricity. And here we are going to learn about many things like Ohm's law, the voltage, the current, the resistance, how to use a multimeter, about the batteries and transformers. Let's move further and start the session. Ohm's law. We have studied Ohm's law in class 10th or 11th, and we are aware that as per Ohm's law, the voltage is directly proportional to the circuit current. As per the George Ohm, at a constant temperature, the electrical current flowing through a fixed linear resistance is directly proportional to the voltage applied across it and is also inversely proportional to the resistance. This relationship between the voltage, current, and the resistance forms the basis of Ohm's law as written at the bottom. So from the definition, we can conclude that the current which is flowing in the circuit is directly proportional to the voltage and inversely proportional to the resistance. So we can conclude that the current I is equals to the voltage V upon the resistance R. The current is measured in amperes. You can see the animated diagram and it explains the Ohm's law very well. Here you can find that the voltage is a force which is forcing the current to flow through the circuit. But at the same time, there is a resistance which is restricting the current to flow seamlessly in the circuit. You can observe that whenever there is a force applied through a material, the current can flow from the circuit, but if the resistance is available, that resistance restricts the current to flow in the circuit. Now, moving further, we will talk about the terms that we have used in Ohm's law, and these terms are the voltage, the current, the resistance, the power, etc. First, we'll talk about the voltage. We need to know what exactly is the voltage. Voltage is actually a force that makes electrons to flow in the circuit. It's a difference in potential energy between two different points in a circuit. When we talk about the voltage, you can understand that the voltage is the potential difference between two terminals. Now we'll talk about the current. Current is the rate of flow of electrons and the current is measured in amperes. The power used in a circuit is measured in watts, and watt is calculated by multiplying the voltage by the current. And the last one, that is resistance. This is measured of how well something conducts electricity. If it has a low resistance, the object is a great conductor of electricity, and if it has a high resistance, that means that it does not conduct electricity well. To conclude these electrical properties, we can consider here the voltage, that is defined a amount of potential energy in a circuit, and the unit of the voltage is volt. Next, the current, the rate of charge flow in the circuit. It is measured in units of amperes. The third one is resistance. It is the opposition to the charge flow. The unit of the resistance is ohm. Let's move further and talk about these terminologies one by one. The voltage analogy. As we have talked earlier, the voltage is just like a force. So here we are taking a water tank and we are going to talk about the voltage in terms of how a water tank works. You might have seen the water tank, and if the water tank is full, the pressure applied because of the gravitational force by the water tank will be more, so more amount of the current will flow in the circuit. In other words, we can say if there are more energy, the voltage will be higher. In this analogy, remember, we are representing the water from charge, the pressure from voltage, and the flow of water in terms of current. Similarly, if the amount of the water on that water tank is less, the amount of the flow of the water will be less because it will offer less pressure. So less amount of the water you will get from the output terminal. So that's why we can conclude that if there is less voltage, there will be less energy. I hope you will understand this concept of voltage. It is nothing but a flow. Now we will see how we can measure the voltage. So to measure the voltage, we need to use some electronic device, and that is called as voltmeter. And voltage is measure of potential electrical energy. A voltage is called as potential difference. It is measured between 2 points in a circuit across a device. Let's understand the concept of measurement of the voltage by the diagram. So you can see here the diagram. There is a battery of 1.5 volt and there are two bulbs connected in series with that particular battery. Now we can use the multimeter and we can measure the voltage at different terminals. So first we had applied the voltage. You can see the mouse. We have applied the multimeter at the battery, and at the battery it is showing 1.45 volts. Now the 1.5 volt is the total pressure which is applied across the circuit. Let's consider the second example, second bulb. Now here when we measure the voltage between these two bulbs, so the first terminal is applied at the top of the first bulb and the second terminal is applied to the bottom of the second bulb. So first terminal is applied to the top of first bulb and the second terminal is applied to the bottom of the second bulb. Now here the total potential difference, or we can consider that as a voltage. The total voltage of the circuit in the multimeter is 1.5 volt. What does it mean? It means that the battery which has applied 1.5 volts of voltage, the same voltage we are getting between the first terminal of the first bulb and the last terminal of the second bulb. So the total voltage of the circuit is equal to the applied voltage. Now we will see what happens when we will measure the voltage between individual bulbs. So we have connected again a multimeter between the first terminal of the first bulb and the second terminal of the multimeter is connected to the second terminal of the first bulb. In this situation, you will find the voltage across the first bulb as 0.75 volts. Similarly, if you will do the same procedure on the second bulb, you will find the same value 0.75 volts, and 0.75 volts on of first bulb plus 0.75 volts of the second bulb will be equals to 1.5 volts, which is applied through the battery in the entire circuit. So this is how we can understand the voltage and we can measure the voltage. Now you can see the diagram at the bottom. This diagram explains how we can measure the voltage. There are two components available in the diagram. On the first diagram, we have connected the voltmeter to the diode, and in the second diagram, we have connected the voltmeter to the resistance. And accordingly, we can measure the voltmeter across the diode plus the voltmeter across the resistance, and the addition of voltmeter across the diode and the voltmeter across the resistance will be equals to the total applied voltage through the battery. I hope you all will understand this concept of measurement of the voltage in any electrical circuit. Many of the times it is very, very important when we are making any embedded systems or when we are making any device. That particular time, depending upon the requirement of the device, we need to measure the voltage, we need to apply the voltage. And sometimes if you require to lower down or to increase the voltage, accordingly some other components will be used in the circuit to lower down or to raise the voltage at that particular area. So now we'll talk about the current flow. As we had seen previously, the voltage is actually a pressure of the water tank. Now we'll talk about the current. So when we open the entire tap, the force is applied from the water tank, and if we open the tap fully, more amount of water can flow from that tap. It means the whole tap, the tap will give the water to its full potential, and that we can consider as the high current. Here also we are using the same analogy. Water is charge, pressure is voltage, and flow is current. If we reduce the tap by rotating the knob, you can see the less amount of water will flow through the tap, and that is going to be presented as low current. So if the amount of the flow of the current is high, that is considered as higher current, and if the amount of flow of the water is low, that is represented by the lower current. If the pressure is more amount of current will flow. It means if the voltage is more amount of current will flow in the circuit. If the voltage is less or the pressure is less amount of current will flow in the circuit. Now we'll see how we can measure the current. To measure the current, again we can use a device which is called as multimeter, or we are having some specific device which is also called as a meter. The current is the measure of the rate of change of flow that we understood from the definition of the current. For electrical engineering, we consider this flow of current is due to the movement of electrons. Let's understand this concept. using the given diagram. So here we have connected one battery of 1.5 volt to a bulb. Now you can see something moving inside the circuit, and because of that the bulb is glowing. That moving particle is called as electrons, and when we apply some resistance in the circuit, also the voltage is applied, some amount of current will flow in the circuit. So the current is flowing in the circuit, and accordingly the bulb is glowing. Now if you want to measure the current which is flowing in the circuit, you can apply uh, an ammeter or the voltmeter to any of the terminal. Like here in the second diagram, between the two terminals of the battery, we have connected the ammeter, and the ammeter is going to give us the amount of current which is flowing in the circuit. I hope you will understand how to measure the current. To measure the current, we can use the device which is called as ammeter. If you don't want to use ammeter, then we have a device which is called as multimeter, and that multimeter allows us to measure using the same device voltage, current, resistances, etc. Now moving further, we will talk about the resistance using the same analogy, and here you can see that the water tank is partially filled with the water, and more amount of the current will flow through the circuit. So here one thing we need to keep in mind, if the size of this pipe is big, then the more amount of the current can flow in the circuit. Because of the size, it is going to offer less resistance. At the same time, in the same way, in the same water tank, if a small pipe will be included, then the current or the water which will go out from that particular pipe will be, the amount of that water will be less. To understand this in terms of the flow of current and offering of resistance, if the resistance is high, the second diagram, if the resistance is high, because the pipe we have used is very small in size, so that's why it offers high resistivity, and because of that the less amount of current is flowing, while in the first diagram the size of the pipe is big, and because of the bigger size, the resistance offered to the water will be less, and that's why more amount of current will flow through the circuit. Now we'll try to measure the resistances, and we know that the resistance is a measure of the opposition to current flow in any of the electrical circuit. So the question arises, how to measure the resistance? You can see the first diagram. The electrons are flowing through the copper wire. This is the copper wire, and the yellow squares are the electrons, and we know that due to the movement of electrons the current flows in the circuit. Here when we observe this, you can see that the electrons on the copper wire is moving freely. At the bottom on the diagram, you can see that the electrons on the copper wire is moving freely. Now, if we attach some resistor, resistor is basically a device which offers resistance in the circuit. So if we attach some resistor, you can see the resistor has many obstacle inside, and because of that the flow of current, the flow of electrons are restricted. So this is the way how the resistor offers restrictions in the flow of the electrons. And to measure this resistance, the same device, multimeter, can be used. You need to put that multimeter on the symbol of ohm given, and then you can connect the two wires, green and red, of the multimeter between two terminals. It will give you the amount of the resistance offered by between those two points. Moving further, today we will talk about the signal, because when we talk about the voltage, the current, the resistance, the voltage, the current, the resistance are offered by some particular material, and because of that something flows in the circuit. What is that flow? What is that something which flows in the circuit? That something is actually a signal. And accordingly, there are in electrical engineering two types of signals we normally use. The first type of the signal is called as alternating current. It is also called as AC current. The alternating current flows one way, then the other way, continually reversing the direction. And AC voltage is continually changing between positive and the negative. The rate of changing direction is called the frequency of the AC, and it is measured in hertz, which is the number of forward backward cycles per second. Now, from the definition, it might be difficult for you to understand what exactly is the alternating current. To understand this concept, we can have the diagram. The definition says that the alternating current is a current which flows in two directions. You can see the first diagram where we had written as AC. Here, for some particular time of instance, the current is flowing towards clockwise, and then after certain time of instant, the current is flowing anti-clockwise. If you see the second diagram, which explains the formation of the signal for alternating current, we can consider you can see here the current is flowing in both the directions. Let me annotate to explain this concept. Yeah. So here, from this particular point to this particular point, this I will consider as first 180 degree, and this as the other 180 degree. So from here, this point to this point is the 180 degree, and from this point to this point, it is again the other 180 degree. Now, when this is the flow of the current. When we start the flow of the current during this point to this point, the current flows like this from this point to this point. And then after suddenly, when the signal changes in this direction, at the lower direction, we get the signal like this, which flows in the opposite direction. So this is the way how a current is flowing in the circuit. Let me clear all the drawings so that I can start the working and you can see. So for first 180 degree of the cycle, we are getting the positive half, and for the next 180 degree cycle, we are getting negative half. And this positive and negative half signals are generating a signal which is called as sinusoidal signal. It is generating a sine wave. Okay, so this is about the alternating current. I hope you will understand the concept of alternating current. The alternating current is a current which flows in both the directions. It flows in the positive direction and then it changes its direction and starts flowing in the negative direction. Okay, and accordingly it generates a signal. In this particular diagram, we have considered that signal as a sinusoidal signal. Now we'll talk about the second type of the signal which is available, and that second type of the signal is a direct signal. A direct signal or a direct current always flows in the same direction. That's why it is called as direct current. But it may increase and decrease. A DC voltage is always positive or always negative. When I'm saying it flows only in one direction, it means that the direction will never change. If the current started flowing at the positive direction, then always the current will flow in the positive direction only. It is not going to change the direction of the flow of the current. And if it started in flowing to the negative direction, then always it is going to flow in the negative direction. But the amount of the voltage or the current may increase or decrease. A DC voltage is always positive or always negative, but it may increase or decrease. Electronic circuits normally require a steady DC supply, which is a constant at one value, or smooth DC supply, which has a small variation called ripple. Cells, batteries, and regulated power supplies provide steady DC, which is ideal for electronic circuit. Normally, when the signal is generated into its natural form, then that particular time the signal is AC. I'm not saying that always the signal can be generated in AC form only. The signal is generated through the batteries or the cells in DC form also. But normally when we generate the signal, when we generate the power, that power is in terms of AC, and that AC power is converted into DC for electronic appliances or elsewhere. If we don't want to convert the alternating power into the direct current, then in that situation, we need to use some other source of power like cells or batteries. We can see the diagram to so that we can understand the direct current. Here, the first diagram you can see, and you can understand the current is flowing continuously in one direction. It is not changing the direction after some time. And accordingly, but the amount of the current which is flowing in the circuit may increase or decrease. Accordingly, in one particular direction, we are getting the output. In the diagram shown, you can see we have taken one sawtooth signal of positive direction, or else the second, we have taken a square wave signal which is also flowing in a single direction. So this is about the DC current, the direct current which we are using. As I told you that when we are generating the signal through our natural resources like water, the signal is generated through the turbine and it is in terms of the AC signal. Now, that AC signal we need to transport from the location where it has been developed to our home. And sometimes, because we are using the conductors for transferring, you can consider that as cable, for transferring the electricity from the source place to the destination place, and those conductors also very small amount of the resistance, but at the same time the length, the distance between the place where the the power is generated to the place where we are going to use it is very much higher. So the conductors also offers small amount of current, but that small amount of current will become very high. Sorry, the current which is transferred from the source location to the destination location, the length, the distance is very high, even though the conductors are offering very less amount of the resistance, but due to the higher distance, that resistance amount will become more and more, and that's why there are more loss of energy during the transmission. So that's why we use different type of mechanism to transfer the energy from where it has been generated to the destination where the energy need to be used. Some of the device which we are using to transfer that is transformer. Also, the transformer is very much important, because everywhere for different devices, when we are using, when we need to apply the energy is not always required at the rate where the signal was developed. I mean that sometimes the requirement is less and we may offer more. Sometimes the requirement is more and we are having less voltage. In that situation, we are using transformers. So transformers are the device that transfers electrical energy from one alternating current circuit to one more other circuit, either by increasing, that is called as stepping up, or by decreasing, that is called as stepping down. So transformer is what? Transformer is a device which transfers the energy from one particular part to other particular part. You can see the first diagram. The first diagram, from the AC generator is getting the charge. Here the coils are available which are wounded, and the power is connected directly from the AC generator to this part. Now the second part is not connected with the first part. It is a separate part, but due to the mutual induction within the coil, or you can say the EMF which is generated at the primary side, the secondary side also induced with that EMF, electromotive force, and the current starts flowing at the second circuit. You can see the second diagram here. The place where the AC generator is connected is called, and here the coils are available. These are considered as the primary windings, and the second part where automatically the current starts flowing due to the induced EMF, electromotive force, is called as the secondary winding. Now we'll talk about the types of transformer, and there are two, as we know, the step up transformer and step down transformer. So first we'll talk about the step down transformer. Step down transformer is that type of transformer which decreases the voltage at the secondary terminal, which decreases the power or the voltage at the secondary terminal. And to make the step down transformer, the basic requirement, using the diagram you may understand, and it says that, or you can, from the diagram you can understand that at the primary side the number of windings are more as compared to the secondary side. So secondary side is connected with a bulb. There is a magnetic flux generated, the EMF generated, and the primary side you can see there are more number of windings at the primary side, and at the secondary side the number of windings are less. So this type of transformer wherein the primary windings are more as compared to the secondary windings is called as step down transformer. What happens? Because of more number of primary windings, the EMF induced at the primary side is more, and that will be transferred to the secondary winding. But because the windings are less in numbers, the all amount of the EMF induced cannot be used, and that's why the voltage at the primary side will be more as compared to the voltage at the secondary side. So in short, if we want to understand this concept, we can consider, or we can understand this as, because the primary windings are more and secondary windings are less, the secondary windings will be capable to get less amount of the voltage or the power at the secondary winding. So in other words, we can say a step down transformer is that type of the transformer which reduces the voltage at secondary terminal. Like here, we may apply 20 volt of power, and here we may get only 10 volt of the power. So the transformers in which the applied voltage or the power or the energy is more as compared to the output power or the voltage or the energy, then that type of the transformer is called as the step down transformer. Okay, now let's move further and we'll talk about the next transformer, that is called as step up transformer. The step up transformer has more number of secondary. Here the red cables are representing secondary and the green cables are representing primary. So the number of windings at the primary side is more. Sorry, the number of windings at the primary side is less as compared to number of windings on the secondary side. This type of the transformer where N2 is greater than N1 is called as step down transformer. And in these type of the transformers, let's consider with some numerical example. Suppose the 10 volt AC is applied at the primary side. Let me annotate. So this is your primary side and this is your secondary side. Okay, now 10 volt of AC signal is applied at the primary side, and if at the secondary side you are getting 20 volt, for some time we'll consider the output that we are getting is 20 volt. Now in this type of the situation, the energy which is applied is lesser than the output energy, then this type of the transformer is called as step up transformer. I hope you might have understood the concept of the primary and the secondary windings, and because of that the transformer functions. In the similar way, these type of the transformers are used to transfer the energy from one place to another place. So what we do normally, we increase when we generate the signal, we generate the signal at certain amount of the voltage. Now that amount of the voltage is increased up to very higher amount of voltage using the step up transformer. So you will get higher amount of voltage at the output terminal. Now that is transmitted. So if there will be a distance, a large distance for the transmission, the voltage will reduce due to the resistances offered by the transmission line. Still you will get some amount of the output, and that if required again step up or step down. So that's why you might have seen the towers, the big towers which has 6 to 8 cables and transmitting the electricity. Those towers are transmitting the electricity at very high voltage. Sometime it is up to 25 to 30,000 of volts, and that's why the size is kept at high also, so that no one can touch that or no one can come near to that, because if you are going near to the electricity, you may get some current also. So that is the reason we are increasing, and that we can do using the concept of the transformer. And these transformers are also used in our electronic circuits. That's all for today. Have a good day.